So in this video clip we're going to look at a type of question that is starting to appear quite frequently on GCSE maths papers. And if you were to give a question like this blind to a maths teacher without them knowing where it came from, they would probably set about it in an algebraic method. But when you notice that these papers are appearing on the foundation intermediate tier overlap, the chances are that as maths teachers we need to be approaching it or teaching it in a different lower level way. So we're going to work through these and I'm going to approach them in two different ways. First of all, we're going to look at it using a trial and improvement method, and then we'll come back in a different video clip and take a look at a bar modelling approach to solving these questions. And before we come to working with the questions, we'll start off with looking at some practice ones. So if we start with this first one, an aquarium contains 80 tropical fish. Some are tetra, some are rainbow, and the rest are angel. So if I use a T, an R and an A for tetra, rainbow and angel, I know that in total they're going to add up to 80 because there are 80 fish in the tank. There are 3 times more angel than tetra. Well, 3 times means you're multiplying by 3. So there's 3 times more angel than tetra. So however many tetra there are, I'm going to multiply it by 3 to work out what the number of angel fishes are. So the angel fishes are going to be 3 times the tetra. There are 10 fewer angel fish than rainbow fish. So there are more rainbow fish than angel fish, and the number more there are is 10 more. So I can write this out as angel fish add 10. And then what we do from a trial and improvement point of view is we choose a starting point. So let's guess that we have 20 tetra fish. So if we have 20 tetra fish, then we will have 60 angelfish, tetrafish times 3, and then we're going to add 10 to that to give us the rainbow fish. So if we add 10 to that, we get 70, and those need to add up to 80, and we've got 60, 80, 150, too big. So let's try 15. There's no point picking a bigger one, so this is why it's trial and improvement. So if we go for 15, if we got 15 tetra, we've got 3 times as many angel, which is 45, and we've got 10 more rainbow than that, so that's going to be 55. So if we add those together now, we get 115, which is too big. So let's try 10. If we got 10 tetra, 3 times as many is 30 angel, add 10 to get rainbow, and if we add those together we get 80, which is the number of fish in the tank. So how many fish are there of each type? So we have 10 tetra, 40 rainbow and 30 angel. So that's the trial and improvement method. Let's try question 2. One day a cafe sells 106 sandwiches. Some are bacon, some are cheese, some are ham, and the rest are tuna. So again, that's the range of sandwiches, and in total they're going to add up to 106. So what information have we given? 5 times as many bacon are sold than tuna. So if I know the number of tuna, I would times it by 5, and that would give me the number of bacon. So that's that bit of information. They sell half as many cheese as bacon. So however many bacon there are, I'm going to divide that by 2 to get the number of cheese. And they sell 18 more ham than cheese. So that there's going to be more ham, 18 more than there are cheese. So that's going to be cheese plus 18. So that's how we're going to generate our numbers, and we're going to generate them from tuna fish. So let's try 20 tuna. So if we choose 20 as our starting point, 20 for tuna, that means we're going to have tuna times 5 for bacon, which would be 100. If we divide that by 2 then to get the cheese, that would be 50. And the ham is cheese plus 18, which would be 68. So you can see there that's going to add up well over 106. We've got 100, 150, 170, 238. So that's way too big. So if we try 50 bacon then, 50, sorry, we don't, this is where we're going to start. So tuna, so let's try 15 tuna. Well, let's make it easier, let's go for 10. Let's go for 10 tuna. That means we're going to have 15, sorry, 10 times 5, 50 bacon. We're going to divide that by 2 to get 25, and then we're going to add 18 to the 25 to get 43, and then when we add those up we get 50 plus 25 plus 43 plus 10, 128. So 10 is too big as well. So if we now try 8, 5 8's 40, bacon divided by 2 is 20, 20 add 18 is 38. So if we add those up, 40, 20, 38, 8, we get 106. So we can stop our search with there. So how many sandwiches of each type were sold? So 40 bacon, 20 cheese, 38 ham, and 8 tuna. Question 3. A garage has 120 cars in stock. Some are Audi, some are Lexus, some are Volvo, and the rest are BMW. And there are 120 of them, so that's going to add up to 120. They have the same number of Lexus as Volvo, so we got the same number of each of those. 1/3 of the stock are Audis. So with this one, I can work out the value for Audi straight away. So that is going to be 1/3 of 120. 3 goes into 12, 4, so that's 40. So we've dealt with that. There are half as many BMWs in stock than Audis. So however many Audis there are, 40, there's half as many BMWs. So that's going to be 20. Calculate how much of each car there are in stock. Well, if I know there are 40 Audis and 20 BMWs, that means that in total I've got 60 Lexus and Volvos, because there are 120 cars in total. So those have got to come to 60, and I know that there's the same number of each. So that one has to be 30, and that one has to be 30. So that one's a bit easier because one of the cars is a fraction of the total amount. So moving on to question 4. Susan's purse contains 33 coins. Some are £2 coins, some are £1 coins, some are 50p coins, and the rest are 10p coins. And in total, the purse has got 33 in, so those are going to add up to 33. Now, what you have to be careful here is to be clear the difference between number of coins and value. So we need to realise that in the first part of this question, we're working with the number of coins. We want them to add up to give 33. So what clues have we got? There are 3 times as many £1 coins than £2 coins. So however many £2 coins there are 3 times as many £1 coins. So we take the number of £2 coins, multiply it by 3, that will tell me how many £1 coins there are. There are 5 more 50p coins than £1 coins. So however many £1 coins there are, I have to add 5, and that will tell me how many 50p coins there are. There are half as many 10p coins than 50p coins. So however many 50p coins there are, I'm going to half it. And that's got to add up to give me 33. Okay, so let's start off. So if I say, let's say we've got 10 £2 coins. That means I've got 3 lots of 10, 30 £1 coins. 5 more 50 pences, 35 50 pences, and half as many 10 pences. Now, I can't have half a coin, so because that's an odd number, I know that's going to break down. And also, it's clearly going to add up to more than 33. So it isn't 10. So if I try 6, let's see what happens with 6. So 6, I'm going to add, then I'm going to multiply that by 3 to give me the number of £1 coins. So there'll be 18 £1 coins. Add 5 gives me 23, and again, that's an odd number, so it's not going to work. So I'm thinking to myself now, okay, so if I'm choosing even numbers here, it looks as if it breaks down. So let's try an odd number. So if I have 5 £2 coins, 3 lots of 5 is 15 £1 coins, add 5 to that, 20 50p pieces, half that, 10 10p pieces. What does that add up to? 30, 45, 50. So that's too big, but because I chose an odd number there, I did get the right number of coins, or a complete number of coins. So I'm going to stick with odd. I'm going to go smaller, so I'm going to try 3. So if I have 3 £2 coins, I'll have 3 3s, 9 £1 coins, 14 50p pieces, adding 5 to that, and then half as many 10s, 7. And when I add that together, I get 10, 24, and 9, 33, which is what I'm searching for. So Susan has 3 lots of £2 coins, and that's going to have a value, working with value now, of £6. She has 9 £1 coins, which will have a value of 9. She'll have 14 50p, which will have a value of £7, and 10 pences times 7 is 70p. Sorry, that was off the page. Let me explain that again then, because you couldn't see me writing it. So 3 £2 coins, so that'll have a value of £6. 9 £1 coins, total value of £9. 14 50p pieces, value of £7, and 7 10p pieces, value of 70p. So the total value of what she has in her purse is going to be 9 and 7 is 16 plus 6, £22.70. So that's where we move from the number of coins to the value of the coins. So there's a mix in that question. So that's question 4. Question 5. A computer shop sells laptop computers, desktop computers and tablets. Laptops, desktops, tablets. They presently have 71 items in stock. So in total, those have to add up to 71. 1/4 of the number of tablets are desktops. 1/4 of the number of tablets are desktops. So another way of saying that is there are 4 times as many tablets as desktops. So we can write that as 1/4 of the number of tablets are desktops. So there are more tablets than desktops, 4 times more. There are 10 more tablets than laptops. So there are fewer laptops than tablets. How many? 10 fewer. So tablets less 10. So we're going to start by choosing a value for desktops. So let's go for 10. That will make that 40, 4 times as many, and that will make that 30. So when I add those up, I get 80. So that's too big. So now if I try 5 desktops, that's going to be 20, 4 times as many, and that's going to be 10 fewer. Add that up, I get 35. Too small. So I need to go somewhere in between. So if I go for 7, 7 4s are 28. 28 less 10 is 18. When I add those up, I get 18 plus 7 plus 28, 53. Too small. So I'll go 8. 4 8s are 32. Less 10, 22. 22 plus 8 plus 32 is 62. Too small. So I'm going to go 9. 9 4s, 36. Less 10, 26. 26 plus 9 plus 36, 71. So I got there in the end. Calculate how many devices the shop has in stock. So 9 desktop, 36 tablets, 26 laptops. And the final warm-up question. In an innings, a cricket team record 33 boundary scores, which are 4s or 6s. They scored 10 times as many 4s as 6s. 2/3 of the total score comes from singles. Calculate the total score made by the team in the innings. So we've either got scores in singles, or in fours, or in sixes. These are the boundaries, so these are going to add up to 33. They scored 10 times as many fours as sixes. So to work out the fours, it's going to be sixes times 10. So if we have 2 sixes, we'll have 20 fours, which is 22, too small. So if we go for 3 sixes, we have 30 fours, which comes to 33. So we know that they've scored 3 sixes and 30 fours. 2/3 of the total score comes from singles. So these are again now just like the Susan's Purse question. These are the number of boundaries. We now have to work out what value they have as a score. So as a score, that's going to be 3 lots of 6, which is 18. And this is going to be 30 lots of 4, which is 120. So the boundary runs are going to be 138 runs boundary. 2/3 of the total score comes from singles. So that means that if that's 2/3 of the total score, this is 1/3 of the total score. So singles is going to be 2 lots of 138. And we want to know what the total score is. So the total score is going to be, well, let's do that. 2 lots of 138 is 276. So the total score for the innings will be the 276 singles plus the 138 boundary runs. So in total they score 414 runs. So that one's slightly different again because the total bit only accounts for part of the problem. Right, well hopefully that's got you thinking about the method for working with these. So now we can look at the actual GCSE questions. So the first one, a shop has 31 plant pots. Some are blue, some are yellow, and the rest are red. And I know that they have to come add up to give me 31. There are 5 more blue pots than yellow pots. So there are more blue than yellow. So if I add 5 to the yellow, it'll give me the blue. And there are 4 times as many blue pots as there are red pots. So if there are 4 times as many blue than red, that means that I've got to divide the blue number by 4 to give me red. Okay, so I'm going to start with yellow and I'm going to guess 10. That's always a nice number to work with. If I guess 10, that means I got 15 blue, and if I divide 15 by 4, I'm going to get a part, and I can't have a part because they're going to add up to 31. So I'm thinking then, okay, that needs to be odd, so I'll go 9. 9 and 5 is 14. 14 divided by 4 is not going to work. It's not in the 4 times table. So if I try 8 and 5, sorry, keep it odd, 7 and 5 is 12. 12 divided by 4 is 3. 10, 22. Too small. So I need to be working with numbers larger than 10. So if I start at 11, 11 and 5 is 16. 16 divided by 4 is 4. And that's going to give me 20, 31, which is what I'm looking for. So I've got 4 red, 11 yellow, and 16 blue. And then the final question. Team A and Team B play in a competition. Team A has 9 more points than Team B. So 2 teams, A and B. Team A has got 9 more points than Team B. So the difference between the two must be 9. And Team A has 4 times as many points as Team B. So that's going to be B times 4. So I'll choose a value of B. Let's go for 10. Times it by 4, 40. What's the difference? 30. No, way too big. So I'm going to go smaller. I'll go 5. 5 4's 20. Difference 15. Too big. I go 3. 3 4's 12. Difference 9. That's it. So Team A scores 12. Team B scores 3. Okay, so that's the trial improvement approach to dealing with questions like that. Hopefully you found that quite straightforward, and you'll be able to tackle those if they come up in the next exam.